Hello, today we are solving LeetCode question number 108. The question says that you have to convert a sorted array into the binary search tree. It means you are given a sorted array as an input. You have to transform it into a binary search tree. So let's understand on the whiteboard how we can try to solve this particular problem statement. So for example, in this case, the input is given as -10, -3, 0, 5, and 9. Let's try to solve this. What possibly we can start with here is, okay, in a sorted tree, what we exactly want in the binary search tree. So in binary search tree, we want some value at the root and all the values smaller. So smaller value will be on our left side and all the larger values on the right side. Now, for example, this is the root and this says that all the values on the left side should be smaller, on the values on the right should be larger. But what if the values are equal? So you have to decide on which side you are keeping that value. So for example, on the smaller side, you say that it is small plus equal values. And on the right side, these are the larger values. So this is where you have to consider. Now we can take the example of this. Okay, since array itself is given sorted, you can, whenever you select any point in that array, it means all elements on the left side is smaller and all the elements on the right side will be larger. So taking this property, we are trying to construct this tree. So what we are trying to do in this sorted array, first we are taking the mid element. So here total are the 5. So if we take the 5, okay, what is the mid of these elements? This is 2.5, which is coming to index 2, which is 0. This is the mid. So first we create a root element with the element 0. Then recursively, we don't solve the problem to construct the entire tree, which says that okay, now on my left side the problem remains that I again have a subarray. On my right side again I have a subarray, and again I will try to solve this problem recursively. Okay, so here on the you solve the problem on the left side, here you problem solve on the problem on the right side. Now when you solve on the left side, again you find the mid is equal to -3. Here we used to try to solve the problem on the right side. It means the mid comes out to be 9. Now you say that okay, this is the -10 and this is 5. This is the one way to solve this particular problem statement. So you construct the tree. Now try to solve this into the code. Okay. So similarly, as we discussed, we will try to solve this problem with the recursion. So we create another method that takes the input of the different index start and the end indexes. So it will return the tree node. Method name we can keep the same, array to bst. Int, we are passing the same numbers array. I am taking here the two left and the right, two diff boundaries of the array. Now what we are going to do, if at any point of the time left is greater than the right, I say return the null. Okay, left has crossed the right boundary. It means whenever you have to return the tree, you have to return a null node. Now you can put if left is equal to right condition as well, but that is not required. Eventually, whenever recursion call, it will come to this condition and eventually it returns the null. So we can directly write the tree node. First, we have to create the root node. So new tree node here in the nums array. Nums array, we are taking what index? We are taking the mid index, but we have not yet defined the mid yet. So first let's create a mid value. In mid is equal to left plus right divided. Okay. So there are the different ways in which you can also adjust. You said that left plus right can increase cross the integer boundaries and the different ways to handle it. But in these questions, that is not required. So I'm just simply doing the left plus right by divided by 2 to calculate the mid. Now to this node, I have to say define what are the child pointers to my left. I said solve this problem recursively. Again, sorted array to bst. Here we are passing nums. My left become left Here is equal to mid minus 1. I have taken the mid element now on my left side from left to mid minus 1. Similarly, on my right side, it will be row to right is equal to sorted array to BST nums. Here mid plus 1 to right elements. And here I'm returning the root element. So this is the method which solves the recursively construct the entire tree. Now I have to just call this method return. We are calling this method. We are passing nums. We are passing 0. We have length minus 1. Let's try to run this method. If all the local test cases are passing, yes. So we see that all local test cases are passing. Now we are submitting this. Okay, so we have successfully submitted. So overall complexity of this method. So if you directly see, for example, nums and every single element in the array we are visiting once, and then we are trying to create the node out of it. So overall complexity of this algorithm is order of n. And that's it. I will come up with more videos. Thank you for today.